I will explain about the trace power cable circuit, starting from isolated switch to the power block terminal and distribute to the controlling circuit system and internal transformer of the frequency converter. For the first component is isolated switch. Isolated grid power supply before usage, ensuring safe disconnected of equipment. Next, for the second component is power input cable. Function is to carry power supply from isolated switch into the power block terminal in the frequency converter. Next component is power block terminal that has three functions. First, safe termination of incoming wires. Second, redirect different phase of power supply into next stage. And third is easiest future troubleshooting. Next is a regulator. Function regulator to regulate the voltage that will be supplied to the PZT transformer. For the next component is output terminal. Output terminal is a channel to regulate output power from FC into PZT transformer. For the second part is trace lamp and alarm circuit, to identify the circuit of the system and connection of lamp and alarm of the frequency converter and the testing catch. For the first component is #lamp and horn. Indicates whether it is safe or not to enter the high voltage lab, and also have siren mounted for warning purpose. For the second component is potential free lamp and horn. Acts simultaneously with #lamp and horn as a secondary warning and safety system. Function is just like the #lamp and horn but have a separate terminal on FC. For the third part is interlock system, to determine the circuit of the system and how the connection of interlock system from frequency converter to the sensor. And the component is #lamp and horn. Act as interlock switch so that the door is closed before testing begin, and help to cut off operation if door is open during testing. For the next part is trace emergency button, is identify the circuit of the system and its connection to the control room. The component is emergency stop button. Function is immediately stops operation in case of emergency and use a key system for safety purpose. For the next part is trace grounding system. Must be considered from the main grounding chamber and its grid at each grounding terminal cell, from the grounding terminal cell to the frequency converter. The component is main grounding chamber. HV lab grounding system is separated from the rest of the building to avoid damage other equipments in case of failure.
Okay, for the next component is copper braid. So it provides safe path for any excess electrical current to be grounded. It connected from the grounding chamber into the lab through a wall mounted channel. So the access is very long, so the copper braid can be connected to every component used in a test. FC have a specially installed bracket to connect this copper braid on the side. Okay, next point is transformer specification and connection. It's to identify clearly the circuit topology, either for the purpose high voltage or isolated transformer of the system and its connection with frequency converter. For the first component is FC output cable. So FC output cable will connect output from FC into PZT transformer. So it have 3 core wire, which is 2 phases plus a ding. Multi-core PVC sheeted flexible cable. Core wire diameter is 2.5 mm, and the connection of the 2-phase wire is interchangeable.
The next component is the PZT transformer. From the frequency converter, the supply will be 415 volt. And then the PZT transformer will gradually step up the supply power until it reach 100 kilovolt. This is because in this lab the transformer is connected in series, so it will give out full potential, which is 100 kilovolt. If the transformer is connected in parallel, the potential will only be half of that value, which is 50 kilovolt.
Okay, for the first, this is a grounding switch. So the grounding switch is a remote control switch which can be used to ground the high voltage construction kit. Okay, second, this is floor pedestal, the conductive element for mounting up to 4 space bars horizontally and supporting one component vertically. So we put the floor pedestal under the grounding switch. Okay, third, we use a 100 kV measuring capacitor that function to use as HV unit for the AC voltage divider. So we plug it in the floor pedestal.
The electrode is the part that directly contact the test object or medium, such as insulation material or dielectric fluid in high voltage testing. It allows voltage to be applied across the insulation being tested. Connecting cup K serves as the interface or holder that helps secure the electrode in place and connect it electrically to the high voltage source. The conductor is the metallic part that carries the high voltage from the source to the electrode. In high voltage system, conductor must be properly insulated and spaced to prevent outswing and maintain safety.
Okay, first of all, we take the SEKAC secondary part for CMAC. We take the banana plug to BNC and then we connect to the SEKAC. And we take the cable BNC. So we connect to the SEKAC. And also for the other side, we also connect the cable BNC to the capacitor. For the next step, we take the banana plug to BNC and T-junction, we connect to the SEKAC. Next, we connect between the HF socket of the measuring capacitor CM and picoscope by means of a coaxial cable BNC.
So, the next step is take the yellow banana jumper cable and then put on the FC or kit control and the other side. We have to put on floor pedestal that connect to our 100 pF capacitor. Next, take copper braid. This copper braid will be bolted in 3 places, namely on the floor pedestal, FC kit control, and finally on the transformer. First of all, we connecting the floor pedestal and so on to FC kit control and lastly to the transformer.
From the FC, we will have 3 wires. First is the yellow earth wire that we will connect to the copper braid for grounding purpose. Next is the 2 live wires, which is the blue and brown colored wire that we will connect to the PZT transformer like this. Since both wire is live, the connection is interchangeable, so you can actually swap between the connection of the blue and the brown wire like this, and the device can still function properly. This is parallel connection, but in this lab we are supposed to use series connection so that we can get the full potential in this PZT transformer.